curious about this, take IT 125 this summer. Might be the last chance that I'm going to teach it. But on IT 125, we talk about databases, we talk about indexes. So what happens if you have a table, right? You have a table. So when you enter data into a database, you're going to have data coming in as it comes in, right? So maybe you enter customers, maybe they're in order, maybe you have invoices, right? So here's the invoice number, and here's, maybe these things come in order, and then here's the vendor ID, the vendor number, right? So this invoice is this vendor, and maybe the invoice total is going to be 3,000. I don't know, I'm just going to make up numbers, right? And then invoice number, maybe these things are in order, but these are not. And then, of course, these can be various kinds of things. And then here's the next invoice, and then here's the vendor, okay? And the total of this one was whatever, okay? This data that comes into a database comes in as it comes in. You're stuck with that, right? You're stuck with that exactly coming in. You have to store the records as they come in. Maybe this is in a database file. Maybe this is stored in memory, depends on how important the thing is, but the things come in order, okay? So can I do a binary search on this file, on data in this file? Well, maybe is the answer. Why maybe? Well, what if these are manually coming in, and maybe these are not coming in order, right? Maybe somebody's manually typing these in and it's whatever order they happen to be in, right? So do I have any chance of having a binary search on any data that's in this file or any data that's in this table in memory?
The vendor is not unique, so you can use that. I don't know if I'm understanding it best.
It might be unique. It's probably not unique, right? So maybe another invoice down the road is going to use that same vendor. Question is, can I binary search on the inventory of the invoice number? Can I binary search on the vendor number? Can I binary search on the total? But if they're not, right here, they are not in order, right? I made some intentionally out of order. I'll make it more out of order, right?
I would say we can't because it's not in order.
Yeah, we can't if things are not in exact order. And even so, even if the invoice number was in order, that would be the only column we could do quick searches and sorts on. So I can't sort by vendor number easily or do a binary search to find the one I'm looking for. I can't do that on the total. And so in a database, do you think that's something that you can bear? Because you might have 1 million rows, right? You might have 1 million rows of data. Do you think that it is possible to go in and physically reshuffle 1 million items in a database table when you want to sort something? Are you going to go do a quick sort on 1 million items just because you want to see them in order of the vendor number or because you want to find a vendor number quickly? Ain't going to happen, right? There is no way that every time you want to sort, you can go physically reorganize this data. There is no way that even if it's in memory, you want to go and physically change all of these things, because then the next minute they want to sort by something different, right? So you just can't bear this, right? You can't have a situation where you can't index things for speed. And so that's what a database has a problem with and the solution for that is indexing. Because what you have over here is you're stuck with, right? The table you're stuck with, whether it's on disk, right? Because you can find things on disk reasonably quickly to do a binary search if you have certain things true about the sizes of the rows, the records. But even if it's in memory, you can't really reorganize the table every time. But what can you do? If you want to sort by, if you want to index by column 2, what you do is you pull that stuff out. So here we've said, look, we want to index by column 2. So we literally pulled out that data and we put it in a separate spot called an index. We literally copied out all that data and we moved it over here and we made this index. Again, could be in memory, could be on disk, but notice all the data is the same here, but now it's organized differently, right? Now, the first one, 11 is the very first one, and then 13. Notice that these are all in order. Why is that nice? Now we can sort. They are sorted, right? We don't have to sort. They are already sorted. How fast can we find the particular data from that column? Log n, right? It's a binary search kind of speed. It's very fast. But now we had to take up some extra memory, right? We had to actually pull that data out and copy it and make a duplicate copy of it. But now look what happens if we want to get an in order listing of all of our table data. What do we have to do? Start here, follow the reference, then go to here, follow the reference, then go to here, follow the reference, then go to here, follow the reference, right? So what is included is you have this data of interest. What does that sound like from our discussion of tree maps?
Is that the key?
This is the key, right? And then you have this other little bit of data, and what is that? That's where to go find the thing, right? Where to go find the thing. Either the record that you can go onto disk and do an offset and go find a certain thing, which is pretty fast, right? Still pretty fast. Or if it's in memory, it's sort of like the row